Hello, this is week 4. This is the second part of this week, which is Spark SQL. So Spark SQL is a query language on structured data processing. So it has a capability to make a query faster. And it can also scale to thousands of nodes to make queries. So we will see a few examples later on. The structure of Spark SQL have several layers. So underneath, we have seen they have CSV, JSON, JDBC. So JDBC is Java Database Connectivity. So these are CSV, JSON, and JDBC are the input data format. And then we have a data source API, which is able to take a different type of data source for us to use. We also have data frame API. So in the previous session, we have learned the data frames. And also, we have a data frame domain-specific language. And we also have a Spark SQL, which is what we are going to learn this part. And also the hypertable query language as well. They're all based on the data frame API. So this is the overall structure where the Spark SQL is sit. So it sits on this. Okay. So this is the overview. So the Spark module can process structured data processing, like database table, JSON files. So they have different ways to manipulate data through data frame API, through SQL query, and through dataset API. So Spark SQL, as I've seen that, it provides an interface, both structured and computation, on the Spark RDD. So resilient distributed dataset, which we have learned before. So this shows that it's a core function of Spark and runs SQL, have SQL queries, can connect to existing business intelligence tool through JDBC. They combine it in Python, Scala, and Java. But the Spark SQL is not SQL. We are going to see difference between them. So, advantage of Spark SQL is we can write less code. We will see a few examples, compile on different ways to process data on the source code. And we also will see examples later on. Because we use Spark SQL, we can actually process less amount of data than SQL, for example, in a smart way. And then they will have automatic optimizer to do the hard work to allocate resources to calculation. First is a less code. Okay. Write less code. Okay. So SQL data source API can read data frame, use very rich range of formats. The left part lists 9 different kind of input data format. We will see example later on, compare with JSON input and compare with sparkSQL input. And also we know SQL, PostgreSQL, and we are going to see a half later on as well. So externally, they will also have different CSV, etc., which can also read and write. So this gives us a very rich capability to reach sources of input format. To write the less code also means it provides a powerful operation. For example, select required columns, join different data sources, and do some operation and calculation, aggregation, and filtering. So we will see example later on this function compared with different other approach. How can we do a join with a less amount computing resources, read a less amount of data? The optimizer, as we say, the optimizer will have us convert logical plan to physical plan. So logical plan is different from physical plan. So logical plan is how the concept we solve problem. The physical plans means how actually they operate in order to achieve the goal. So we will see later on that if the logical plan remains the same, but if we do the physical plan differently, we probably can reduce the amount of data we will need to read. Logic plan is a street representation representing data and the schema. So data is the records, the set of records. Schema is the list attributes. So the tree is manipulated, optimized by catalyst rules. So this is a float which shows the process. At the beginning we analyze. So the query and the data frame. So data frame contains data. The query, we make query on the data frame to extract information. And the logical operation, we will see later on the logical plan as an example, how we optimize the logical plan and what the different, once we have the logical plan, we carry out on the physical plan, which is how we make a cost operation or select a certain physical plan and operate on resilient distributed dataset. So this optimizer, which have advanced program language features, so they have key purpose for doing this one. They can add new optimization techniques to sparkSQL. They can enable external developer to extend optimizer. For example, add additional data source rules, support a new data type, for example, so they can extend current the optimizer. So let's look at the comparison before about the less code. So we talk about the advantage of sparkSQL is that this sparkSQL will help us to write less amount of code. So this is a comparison between Hadoop code and the Spark code, sparkSQL. You can see that it's clearly here. We use map reduce. So Lambda is the service we have learned in week 1 or 2, which will have us locate calculation automatically. Okay, and then this program they are doing the same functions. Basically, to read a text file and divide them by space, split them by space. And then, for example, we can read that we got a file, we read a table in, we have two tables, one is input, one is output file. And we carry out to find what's the key, what is the value of that. So key is the text, for example, the keywords, and the value is how many words. For example, if we are doing a count, and we state value into the output, okay? And then we create one table, and then create another table, new class, so it's average. And then we use reduce to see we can aggregate the total number or average number of the values. However, if we use sparkSQL, our process will be much simpler. We just need to define it, and then they will automatically define map reduce for us. And at the end of the function, we just need to collect everything. So we don't need to do any operation on average or whatever. So they will automatically do that for us to generate a list which contains key and their value. So if we look at the same sparkSQL code, code, compare it with SQL and use data frame. So use SQL is also quite simple, which we specified attribute name and also the attribute name with operation from the table, and the group by name. Group by means if we have several name happens, we group them together, and the name is the variable and the group by name, so they are not going to group by average age, etc. So use data frame, so we specify the table name, we group by the variable name, and we do the average or aggregation on two variables. One is name and one is a processed average of another variable, and we do collect. So read data less data, we will see later on example how SQL can help us read less data automatically. We will see example. So we will convert into more efficient format, use columnar format, we will see example, and use partition. So we divide things. And then we skipping data, use the statistic, and push predictors into storage, for example, Java database connectivity. So now we are going to see how we can read less amount of data. So this is a logical plan for this code. This is their physical plan. So we look at these two at the beginning. Okay. So this is a definition, user-defined functions, and then we make actually JSON data format into this data event. So that's actually data. So now we make some filtering. We only think about the event in city, Palo Alto, in some specific place. We are not considering any places as well. And then we select depend on the timestamp for this particular city and make the list, collect them. Okay. So this is the function we defined. So we got the input, which is event. So we got another table, which is about the list of users. So we join the event table with the user table. So this is event table, this is user table. Only event user ID equivalent to user ID, we will join them together. So and then we got a city location zip file. So sorry, zip is the postcode, list the postcode. Okay, so that is the function we called. So you can see the logic plan is got one user table, got the event file, which is here. So we join them together, and then we find out. So that will be two tables joined together, and then we find which event happens in this location, and also we find out the user actually attend this event, and then we list the time stamp of that. So that is how we think logically, but actually we can do it differently. So before we do join, we only select amount of user. So that is the condition we set up, which will reduce significant amount of user which operate on join. So imagine in this table we had 100 users, but after we operate on the filter, probably we only have 10 users. So then the amount of data we need to do join is very small. Also the event, as we have seen that this Palo Alto is a city, which, I mean, in the database, imagine we have 100 cities, but only one has this location. So this will also have us reduce the amount of the record to do the joint. And then only join on relevant user. So this one, relevant user and the relevant event. So this make our operation much cost efficient and require less amount of computational resources. Okay, this one is the only difference between this code and this code is here. We highlight in red. Okay. Okay, so sparkSQL is a column format. They automatically convert to mutable for compatible rhythms. Okay, so they cannot. Okay. So the source code are the same. Yeah, the difference is the data format. So the physical plan with a predictive push down and a column pruning, what they are going to do, you can see that basically they scan the event and optimize at the same time, and then scan event and optimize at the same time. So by doing so, from 3 steps we can squeeze to 2 steps, and just optimization and the join, without go to 1, 2, 3 step. So make our read less amount of data and save more computational resources. So we have seen this diagram earlier. So data frame SQL, sparkSQL share the same optimization pipeline. However, sparkSQL have some limitations, which probably we need to pay special attention to. Based on resilient distributed dataset, because the resilient distributed dataset, we need allocate data to many different nodes, different machines, which means that each one have a immutable copy, and which is specific useful, because when we lost some failure in some nodes, we are able to recover them. However, the limitation is that you cannot change it. In SQL for relational database, we can do this update, insert, delete without any problem. But for sparkSQL, because the resilient distributed dataset, we cannot change the table. We cannot even delete anything, so the original table remains the same. So sparkSQL, they work on the data frame, and the methods are more efficient, and they can also interpret query similar relational database. However, as we have seen before, some function cannot be used in SQL, sparkSQL. So these are the methods which share similarity between sparkSQL and normal SQL. Although the name of the method different, the functionality are similar. For example, filter and select and group by. So data frame have this function which has similar function in SQL, although they use different syntax. For example, I select in my data frame, this is the loss name, is the attribute name, and this is the function which extract the word with lost two words. Okay, let's select. So they will return the record with which lost name and with this. Okay, and the join as well. So on this condition, we do join. And this condition, if both of them true, we do join. And the show is a list result. So we can also see the example from our previous code. For example, when we join two tables, this is the user table, this is the event is event. So we joined on the condition only if the event has a variable called username, and also user has a username called user ID, only if they're equivalent to each other. And also we can use while condition. We can also use while condition so that something equivalent to something we work only on the event which is satisfied the requirement condition. And also you can see here we select event which have one attribute, we select them. We'll not select everything on event table. So all these things can have us reduce significant on the amount of data we operate. So this one also have some functions. For example, we register a table and create view, temporary view on our customer table. So sometimes we did some operation, we want to view them, we can create or replace with customer table. So also sparkSQL can also make statements like SQL. For example, this one, select everything from customer table, which is a standard SQL query, which now the sparkSQL can take this statement to operate on the data frame. Okay, this is summary. So they have, Jeremy has listed some documents, for example, sparkSQL programming tools, and also the book about the data frame. So this is the end of the week 4. So during this week, we have learned two things. One is data frame. Another one is the data frame structure. And then we also learned the sparkSQL, which operate on the data frame. So in this week, just give me 1 second. So that is the end of this week, and I think we are going to see some example and exercises on this. So thank you very much.